Here's a twist that surprises many Python developers. Threads don't actually run your code in parallel. Let's see why. A thread is a separate flow of execution within a single process. Think of a process as your Python program running in memory. Within that process, you can spawn multiple threads that share the same memory space. Each thread executes independently, switching between tasks, which gives the illusion of doing multiple things at once. Python's threading module makes creating threads straightforward. You define a target function, create a thread object pointing to it, and call start. The new thread begins executing while your main thread continues. You can also pass arguments using the args parameter. Now here's the catch. Python's global interpreter lock, or GIL, ensures only one thread executes Python bytecode at a time. This lock protects Python's memory management from race conditions. For CPU-intensive tasks like number crunching, this means your threads won't actually run in parallel, they'll just take turns. However, when a thread is waiting for I/O like network requests or file reads, the GIL is released, letting other threads work. So when should you use threads? Perfect for I/O-bound tasks like web scraping, API calls, or database queries where you're mostly waiting. For CPU-bound work like image processing or data analysis, use the multiprocessing module instead. It bypasses the GIL by creating separate processes with their own memory, giving you true parallel execution. Bottom line, threads in Python share memory and excel at I/O concurrency, but the GIL prevents parallel CPU execution. For that, reach for multiprocessing. Now, go practice this answer. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.